The next question is regarding the national savings. Consider the following. Income is equal to consumption as a function of disposable income plus investment as a function of rate of interest plus government expenditure, which is autonomous here, and net exports, which is the function of real rate of real exchange rate, and disposable income is equal to total income minus the taxes paid on that very income. It is given that the income is 5,000, government expenditure is 1,000, taxes are 1,000, consumption is a function of autonomous consumption, which is 250 plus 0.75, which is moral propensity to consume, times the disposable income. Interest is equal to 1000 minus 50 times R, by R is the rate of interest. Net exports is equal to 5000 minus 500 minus 500 times E, which is real exchange rate, and rate of interest is 5. If government expenditure decreases by 750, then the national savings increase by, we are supposed to find out. We know that the savings will be equal to total income minus consumption minus the government expenditure. When we subtract consumption and savings, consumption and government expenditure from the total income, we get the national savings. So specifically in this question, it will be equal to y minus consumption function is being given us as 250 plus 0.75, and disposable income, as we know, or let's write it y subscript d minus the government expenditure. Okay, so national savings will be equal to total income is 5,000 minus we have 250 plus 0.75 times disposable income is the total income. We know that disposable income is total income minus taxes. Total income is 5,000, taxes is 1,000, so we will get here 4,000 minus the government expenditure, which is 1,000. So national savings will be equal to 5,000. So we have here 5,000 minus now let us see 75% of 4,000. So we have 75 divided by 100 into 4,000. So I'm too lazy to do calculation. So we have 0, 4 5s are 20, 4 7s are 28, 29, 30. So we'll get 3,000. So we have negative 250, negative 3,000. Okay, so national savings will be equal to, so we'll get 5,000 minus 3250, this minus 1,000. Why I have written this? Because this is our consumption part, this is our expenditure part. That's why I have written it. So this is our income minus consumption minus government spending. So it comes out to be 750. Okay, so 5,000 minus 1,000 is 4,000, 3250, it will get 750. Now this is our initial savings. Now what will be the new national savings? So if government expenditure decreases to 750, okay, what happens then? Our national savings will be equal to the income minus consumption minus the government expenditure. Now see here, if government expenditure is autonomous, it will have no impact on consumption or income. So our national savings will be new savings. Let us denote it by S prime. It will be equal to income minus consumption minus the new government expenditure. Let us denote it by G prime, which is 750 here. So new savings will be equal to 5,000, which is our initial income, minus consumption is 3250 minus new government expenditure, which is 750. So it will come out to be 5,000. Okay, let me do this calculation. 3250, we have 3250, then we have 750, 0.5 के 10 आज के 9 तक 10 तक, so it is 11. So it is 1,000. Now what is the change in the savings? That is the new savings minus the initial savings, which is new savings is 1000 minus initial savings was 750. That means the change in the savings is equal to 250. That means national savings increased by 250 in this case. Next question is, consider the following equations for a closed economy. That is, savings at a time period of t is equal to a times y at a time period of t. Okay, t is our time period. So investment is equal to g times y t minus y t minus 1, where ST, IT and YT are savings, investment and income respectively in the time period t, and A and G are positive constants. Okay, we are being told that y naught is 100, A is 0.5, G is 0.6. We have to find out the value of y2. Okay, so let us solve for the equilibrium condition first. So at equilibrium what happens? So at equilibrium our savings at a time period t should be equal to the investment at a time period t. Okay, that means savings is A times YT, it should be equal to G times YT minus YT minus YT minus 1. Okay, having said that, now let us solve it for, solve it further. So we have A YT is equal to G YT minus G YT minus 1. Okay, if I further solve it for YT, so YT will come out to be G divided by G minus A times YT minus 1. I don't have the space here, so you can, when you solve it, you will get this very thing. Now we are being told that we have to find out y2. Okay, remember, so to find out y2, first we need to find out y1. Okay, so given this equation, let us first find out y1. So in place of time period t we have 1, so we have y, in place of t we have 1, will be equal to, so we have g, so g is being given us as 0.6 divided by g again 0.6 minus a is 0.5 times y t minus 1, means t is 1 minus 1. Okay, 1 minus 1 is y naught. Okay, it is y naught here, and it is equal to y1 is equal to 0.6 upon 0.1, 0.6 minus 0.5, and y naught is 100. Okay, so we will get 6, so 6 upon 1 is 6, so 6 into 100 is 600. So y1 is 600. Now y2 will be equal to, again this, in place of t we have 2, so we have g divided by g minus a times y t minus 1 means 2 minus 1, so 2 minus 1 is 1. Give the values their values. We have 0.6 which is g, then we have g again 0.6 minus 0.5 which is 0.1 into y1 we calculate as 600. So 6 divided by 1 is 6, 6 into 6 is 36, so y1 will be equal to 3600. So the answer should be 3600. The question is regarding the multi-plant monopolist's profit maximization. Consider a firm having monopoly of two goods X and Y. The market for the two goods do not interact. The profit function is, profit is a function of the quantities of two goods X and Y, which is equal to 25X plus 13Y minus 2.5X square minus 5Y square plus XY minus 10. Where X and Y are the quantities of two goods X and Y respectively, we need to find out the maximum profit. Okay, so the profit maximization condition is, since we are being given the profit function is, profit is a function of two goods X and Y, which is equal to 25X plus 13Y minus 2.5X square minus Y square plus XY minus 10. So profit is maximized in case of monopoly when the marginal profit with respect to good X is equal to 0. That is partially differentiating this with respect to good x. So derivative of x is 1, so we are left with 25. Derivative of second term will be 0 because we are taking partials with respect to x. Since it is y, its derivative is 0. Minus derivative of x square is 2x, so 2 into 2.5, which is 5x here, and exponent is subtracted by 1 by power function rule. X raised power n becomes n times x raised power n minus 1. If we have x raised power 5, its derivative is 5 times x. Exponent becomes coefficient and exponent is subtracted by 1. So 5 minus 1, which is 4, which is 5 x raised power 4. Likewise, in case of x square, we have its derivative is 2 becomes coefficient and 2 is subtracted by 1. So we have 2 x raised power 1, and we don't generally write the exponent as 1, we write it as 2x. That is how it became 2x. Now, since it is 2 times 2.5, it became 5x. Okay, I don't need to give the explanation to other things here. Derivative of this term is 0, derivative of x is 1, so we are left with y. Okay, and derivative of a constant is 0. So for profit maximization, marginal profit with respect to good x should be equal to 0, and we set it equal to 0. Okay. Likewise, for second good, the profit with respect to second good y, it should be also equal to 0, which means partially differentiating with respect to good y. So we will get in this case, so derivative of y is 1, its derivative is 0 because we are taking derivative with respect to y. So we will get 13 minus 2y. Okay, y square becomes 2y, its derivative, plus derivative of y is 1, so we are left with x, and we set it equal to 0. Okay, now let us suppose this equation first, this is equation second. Let us solve equation second for x. So x will be equal to 2y minus 13. Okay, if I transpose this term here, it becomes positive, 13 becomes negative. Now we plug the value of x here. Okay, so we will get 25 minus 5 times 2y minus 13 plus y is equal to 0, or we will get 25 minus 10y, minus into minus is plus, 13 into 5 is 65, or 5 3s are 15, 5 1s are 5, that is 65, plus y, and it should be equal to 0. Or we have 65 plus 25, which is 90, y minus 10y plus y is negative 9y, it should be equal to 0, or 9y is equal to 90. Dividing both sides by 9, y will be equal to y should be equal to, okay, so we got y is equal to 10. But what about x? Now plug y is equal to 10 in this, so x will be equal to 2 times the value of y is 10 minus 13. So 2 tens are 20 minus 13, which is equal to 7. So optimal quantities of good x is 7 and of good y is 10. But we are supposed to find out the maximum profit. Now plug the value of x and y into the profit function. So pi, so we have x is 7, so we have 7 and 10. Plug, we have 25 into 7 plus 13 into 10 minus 2.5 into 7 square, which is 49, minus 10 square is 100, plus 10 into 7, which is 70, minus 10. Solving this, we should get 142.5. I have calculated the calculations, so this should be answered. That is 142.5. okay. In this video, we will solve the questions asked in JM Economics paper of 2026. The first question is, consider the following information in case of negative production externality. We have P is equal to 15 plus 0.08 Q. This is our supply curve, and P is equal to 40 minus 0.15 Q. This is our demand curve, where P is the price and Q is the quantity. If the marginal external cost is 0.06 Q, then socially efficient equilibrium prices we are supposed to find out. Okay, so what we are being told here, and if I draw the graph here, let us suppose we have the quantity on the horizontal axis, price on the vertical axis. We are being given the supply curve and demand curve in case of negative production externality. Okay, and we are supposed to find out the socially efficient equilibrium price. Socially efficient equilibrium price. Now, socially efficient equilibrium price occurs where the marginal social cost is equal to the marginal social benefit. By this, what we mean? Let us see. Now, marginal social cost means the marginal private cost plus the marginal external cost. Marginal external cost. Now, how does this marginal external cost arise in this case? We have the negative production externality. By negative production externality, it occurs when the production of a good or a service imposes a cost on the third party. Let us suppose a factory polluting a river which harms the local fishermen or the residents' health. Okay, so if a factory is polluting, it affects the third party here, that is the fishermen or the residents. So to find out the socially efficient equilibrium price in case of negative production externality, what we need to do, we need to equate marginal social cost with the marginal social benefit. And what is marginal social benefit? It is simply our demand function in case of this question. So we have marginal social benefit will be 40 minus 0.15 Q. Now, marginal private cost is our supply curve, which is being given as 15 plus 0.08 Q, and marginal external cost is being told us it is 0.06 Q, 0.06 Q, and it should be equal to marginal social benefit, which is 40 minus 0.15 Q. Okay, so graphically, if this is our marginal social benefit curve, this is our marginal social cost curve, this will give us the efficient, the equilibrium quantity, socially efficient equilibrium quantity and price. Okay, now equating them with each other, which means, so we have this thing and this thing, so transpose it here, it becomes 0.29 Q. Okay, if I transpose 0.15 here, so it will get added with this and this term. So 8 plus 6 is 14 plus 5 is 29, so we will get 0.29 here, and it should be equal to, so 40 minus 15 is 25, dividing both sides by 0.29, we will get Q will be equal to 25 divided by 0.29, and it will come out to be roughly as 86. I have calculated it 86.207. Okay, so this is our socially efficient output, that is 86.207. Now to find out the socially efficient equilibrium price, plug this point, this equilibrium quantity into the demand function. That means P will be equal to 40 minus 0.15 times the socially efficient output, which is 86.207, which is 40 minus 0.5 of 86. I have calculated it somewhere 12.93, and we will get 27.07 as the socially efficient equilibrium price, that is 27.07.